Okay, now let's begin activity 2. Activity 2 first has us doing some observations with lens B. Unfortunately, those are really difficult to capture on video, determining whether the image is upright, inverted, real, all these things. We can't really tell unless you're here in person doing it. So I'm going to ask you to go ahead and fill this table in using the two equations in the introduction, namely the lens maker's equation that involves the image distance, object distance, and focal length, and the magnification equation. Using those, we can fill in this table. Without doing any measurements, we can just do the calculations and fill this in, because it doesn't seem very practical to capture this all on video. I tried it and it's not really working out. So we're going to go ahead and skip to the second part of activity 2. Experimental setup using lens A, and what we're doing here, I already have the first measurement sort of set up to show you how these measurements will take place. We are positioning our lens A on the 50 centimeters mark. Our source is positioned on the 0 centimeters mark, and we're going to move the screen until we get a well-defined resolved image of the source, and then we're going to go ahead and mark down these positions. And so we'll have the object distance, the image distance, and we're going to use this equation here to do a linear least squares fit to determine the focal length. So what we're going to do is we're going to position this first at 50, we're going to move the screen until we get a resolved image, and then we're going to sequentially move the lens closer and closer to the source, making measurements of the screen to lens distance at all of these different positions, and then we'll get a slope, intercept, and correlation coefficient. And at the end of it, the goal is to get an accurate determination of the focal length of the lens, and ultimately we'll compare it to our approximation that we did right at the beginning.